The boy and little boy will be my helpers today. Their first task is to take the ladder over there. Let's see if they get the concept of center of gravity. Wait. Oh yeah, huh, there we go. Now little boy can actually carry some of the weight rather than just tilting it up. Ah, and there's my favorite door. Favorite door ever, look at that thing. How to solve cliff problems and free fall problems. Let's learn physics. Concepts we're dealing with: the acceleration of gravity is 10 meters per second every second. Down. Up will be positive generally, down will be negative generally, and, important equation, the displacement is the average velocity, not just the initial to the final, the average velocity times the time. Now there's some practice in here too, so I'm going to ask you to stop the video so you can practice. So really, stop it. See if you know what you're doing. So remember that G is 10, and that up is positive and down is negative, and those directions are essential. First problem, we're going to drop a unicorn from a cliff, fill in the chart for velocity and position.
Hola, ninja.
He thinks he's a ninja. He always does that with his hood. Here it is,
Dale.
dropping.
Eso,
right.
perfecto, hijo, gracias.
So, first thing, it's 10 meters per second every second, and down is negative, so negative 10, negative 20, negative 30, negative 40. That's the velocity column. And remember that the position, the displacement, is the average velocity times the time. So take the average of the first two velocities and multiply by the time. 0, negative 10, average is negative 5, times 1 is negative 5. Position at 2 seconds. Average of 0 and negative 20 is negative 10, times 2 is negative 20 meters, is how far it's gone. Position at 3 meters. Average of 0 and negative 30 is negative 15, times 3 seconds is negative 45 meters. And at 4 seconds, average of 0 and negative 40 is negative 20, times 4 gives you negative 80 meters. That's it. Here's the next problem. Boulder is thrown down at 5 meters per second velocity on Earth.
Listo.
The boy,
Eso.
he's a lefty. Same acceleration of gravity, but a different starting velocity, 5 meters per second down. Same exact equation. Displacement is average velocity times time. Stop it on the next slide. Now, figure it out. First column starts at 5 meters per second down, adds 10 meters per second down every second. Stop it again. Find the position, average velocity times time. These numbers will go quick, so you probably want to stop it here too, but the average of 0 second velocity and 1 second velocity times the time, and successive numbers gives you that. New problem, still on Earth, but thrown up at 15 meters per second. That's 33 miles per hour. Boy, again. Good throw. Here's the first set of numbers. Just subtract 10 every time. Goes up, starts going down again. The negative means down. Here's the other set of numbers. Average velocities, multiply by time. Watch for symmetry. See the symmetry in these numbers? 1 second and 2 seconds, 0 and 3 seconds. Exactly the same thing because it's going up and coming down and the acceleration is constant. New problem with a twist. This is on the moon. Baseball is thrown up at 15 meters per second, but not on the Earth. On the moon, we're going to use G as 2 because it's a nice convenient number, and 1.6 rounds off to 2. This is the same throw as before, but 1/6 speed. That's fascinating. Stop it. Solve the problem on this slide here. Totally different thing. Same idea though. Loses 2 every time. Doesn't even get to the top in that 4 seconds. Solve for the position. That's what you get. Average velocity times time. It goes really far. New problem. You drop a bowling ball from a bridge. Not a good idea. But you time it. Lands in 4.5 seconds. How high is the bridge? How high is the distance or displacement? So you need the average velocity. It goes from 0 to 45 in 4.5 seconds. Multiply the average times the total time and you get 101 meters. In reality, air friction will decrease the acceleration, and so in that time of 4.5 seconds, it'll go less distance. I was at a friend's house and we were shooting a potato gun and we wanted to find out the initial velocity, so we timed it up and down. Stop it on the next slide. Find the muzzle speed. That was pretty easy. 8 seconds, 10 meters per second. Every second you get 80 meters per second. It's like 175 miles per hour. Crazy. Imagine getting smacked in the belly with a potato going 175 miles an hour. If you think that's right, you're wrong. If you weren't paying attention, now's the time to. That goes up 4 seconds and down 4 seconds. The top speed is 0, so it's not 80 meters per second. It's only 40 meters per second, and that's 90 miles per hour. Be careful. Don't just watch the video. Solve the problem and think about it. New problem. Baseball thrown up 25 meters per second. How high does it go? Stop it on the next slide. Solve the problem for height. Quick calculation. Time to the top is 2.5 seconds. Average velocity is 12.5 meters per second. Multiply those two together, you get 31 meters for the height. All right, last problem. Stand at the edge of a cliff. Fire a cannonball up at 45 meters per second. Cliff is 300 meters tall, so find the final velocity before it hits the ground. Stop it. Next slide. That one give you more trouble? Well, it should have. And this is the way to really solve it. Get 90 meters per second. Except you don't. You should get negative 90 meters per second because when you take the square root, you need to choose the negative value. It is down at the base of the cliff. Many of these cliff problems and free fall problems are not that difficult, and they can be done with quick skull calculations. Just remember that the acceleration of gravity is 10 meters per second. Every second down, up is generally positive, down is generally negative. And remember that the displacement is the average velocity times the time.